for some reason that has that sound has the same effect on me as my alarm clock does. This meeting is being recorded. Oh my God, it haunts me. It haunts me to this day. Okay, so welcome to ACM Hacks fourth tooling series. This one will be on LaTeX. This is a pretty fun topic to be able to do a workshop on because it's applicable to a lot of different majors, not just computer science. Although if you're in computer science, it's super useful. If you're in math, it's really useful. Linguistics, physics, chemistry, LaTeX is a very useful tool. So let's get started. Okay, so first, if you're wondering where these slides are, or if you want to know where the README is, which I will be kind of following along, the links are there. And then also the membership code for like the attendance thing it's LaTeX. Yeah, there we go. Okay, so just a quick overview of what we'll be talking about today. Oh, thank you, Jody, for putting the links in the chat. We're gonna first, in order to start using LaTeX, we've got to know what it is. So I'm gonna talk a little bit about what LaTeX is. Then we're gonna take a brief note and talk about the history. After that, we'll answer the question of why would you use LaTeX? And then the majority of what we'll be doing will be using LaTeX. And to do this, we're going to use Overleaf. Overleaf is really nice because you don't have to install anything. It kind of does a lot for you. So for learning how to use LaTeX, it's a really, really useful tool. Let me do a quick thing here. Sorry. I think it's being mean to people who are, yeah. Give me this one. Okay. And some of you were having trouble accessing the slides is because it wanted you to be part of, like, you use your UCLA email account. So that should be fixed. All right. So first kind of question, what is LaTeX? So LaTeX, aside from being commonly mispronounced as LaTeX, is a document preparation system. So you can actually think of it kind of like Word or Google Docs. They do similar things. The purpose of these programs is to create documents. And all of these tools can be used to format your documents in specific ways you want. So like some similarities, we have, like, you can make tables in most of these programs. You can include images in most of these programs, and obviously formatting text. So the main difference between something like LaTeX and something like Word, like Microsoft Word, is Word and Google Docs kind of uses philosophy of what you see is what you get. So when you're editing a Word document, the page is when you, like, print it, it's going to look kind of like how it did on your screen. And that's kind of one of the nice things about Word is you get this, like, very basic, like, it's very easy to see what you're working with. Now, LaTeX kind of came from a different angle. LaTeX kind of comes with the idea of, I know how, like, a paper should be formatted. So as a user of LaTeX, you're not going to be super concerned about formatting as much as content. So the philosophy of LaTeX is that you edit a plain text file, something that's might look a little bit similar to like HTML or Markdown, and LaTeX will handle the formatting for you. All right. Okay, so a brief history. So LaTeX started with a program called TeX, and the inventor of that program was Donald Knuth. And there's actually a little bit of a story behind TeX. So when Donald was writing his unfinished book, The Art of Computer Programming, his publisher offered him a typesetting system, and he really didn't like it. So they sent him some like samples and stuff, and he's just like, no, I don't want to use this. So he spent what should have been 6 months, like that was the original plan, but he actually spent 10 years creating a program called TeX, which is a way to typeset on a computer. So like many programming languages, we've seen like they adapt, and TeX also adapted. So Leslie Lamport created LaTeX on top of TeX by adding some features and macros. And this is kind of like if you have a little bit of experience with software and how software gets developed, this is a very common trend. You look at like C to C++, or arguably Java to C Sharp. This is iteration that happens. So that is kind of TeX to LaTeX. All right. So we answered this question a little bit already, but one thing that many people will ask is why use LaTeX? So apart from kind of looking cool, LaTeX is better than Microsoft Word and Google Docs in several ways. So the main thing for me is typesetting math. Math equations are notoriously annoying to do, especially on something like Google Docs. If you've ever tried to write a good-looking math equation on Google Docs, you will know my struggle. But LaTeX provides a really, really nice interface of typesetting math. An additional little bonus is some online forums actually support LaTeX. So we'll dip into that a little bit near the end. But that's kind of a cool thing. Another thing is you get full control of your document. If you kind of learn and you know how to use LaTeX, you can achieve a lot of little formatting things very, very nicely. And you get a lot of, you kind of gain access to all of the little like fine-tuning knobs of formatting. And then one additional point is citations and references can be made very easy with LaTeX. So, alrighty. So just to get a little taste before we start, here's one thing you can do with LaTeX is you can write a proof that looks like it kind of came out of a textbook. So here's this one from stats, I think. So you notice that the equations kind of just like, they're aligned really nicely. You see all the equal signs are aligned with each other, and we have these fractions look really nice. So we got that. You can insert code into documents pretty easily, and you get like a type of syntax highlighting, which is really nice. And you can even create diagrams like this. So here's a debouncer, I believe. It doesn't really matter, but this is like a pretty cool thing. So, and that is, it's done with LaTeX. All right. So like I mentioned before, we're going to be using a website called Overleaf. So that's what I'm going to be doing my demo in. So let's go ahead and just shift into a web browser. Oh, I am in a web browser. Let's shift into a different web browser, shall we? I'll grab this and then just, here we go. Does anyone have any questions? If you have any questions about LaTeX in general, feel free to drop them in the chat, and we can try to answer them. Cool, cool. Okay, so here's overleaf.com. Like most websites, you have to create an account, but it's free, so it's all good. The interface is pretty intuitive. So if you want to make a new document, you can click on New Project. It gives you some options. I'm just going to choose blank. It'll prompt you for a name. I'm going to call it Galen Senpai 3. Galen is worked on a lot of the content for this workshop, so credit goes to him. Okay. So it gives you kind of this boilerplate, but since we kind of want to start things from scratch, I'm just going to remove it all. Okay, so in short, you can get started with this. So I'll show you. You don't need that. And then I can explain kind of what this is doing. So when I'm thinking document, and that follows by an end document. And then for now in the body here, I'll just type hello world. So in Overleaf, if you want to, you have this like interface of here's like a kind of the source for your document. And then this is like what it'll look like. But this is not updated. And if you want to update it, you can hit this recompile button up here, or you can press Command and Enter. On Windows, it'll probably be Control and Enter, but I'm not sure. If you mouse over this button, it should probably tell you. Okay, so let me make this a little bit bigger so people can see. We just get hello world. Yeah, so one thing you'll notice is that we see like a basic command formatting here. For example, document class and then article. This format, you can think of it like, I forget which is, command name, which is document class, and then in curly braces will be an argument. So what this is saying is like this document is like, it's an article. So there are a few different ones. I think like you can typeset books, like full books in LaTeX, letters, exams, even slides. So that's pretty nice. And then the next two commands down here. So we have a begin and end. These are really, really important. So begin and end define what's called an environment. And what that means is within that area, so between begin and end, formatting rules will apply. In this case, the formatting rules for a document. So in this like particular environment, all of our text is going to go inside of this document environment. So that's important to know. Alrighty. So a lot of times, like one of the first things you read when you are reading a paper is the title. And LaTeX actually provides a really nice way of just creating a title. So how you do this is under here, you can say slash. So this is another command. We're going to use a title command. And then in the argument, we're going to pass the title of our document. So I'll title this one Learning LaTeX. Right, okay. So that's great. And then, but you can also do more. So you can put like author, and we'll see, I can just put my name here. Oops, that is misspelled. Or even the date. So we can say April 30th, 2020. Okay, but then you notice when we compile this, or when we update the screen, nothing shows up. And the reason for that is like I said before, all of the text that goes in the document will be in between this begin and end for the document. So what that means is that I'm probably going to need to do something inside of this document area for a title to show up. So I can actually just type the make title command. And then once I compile that, we should see a title. And this is kind of an important idea, is that this is just all like kind of information, right? All I'm doing here is telling LaTeX, hey, the title of this paper is Learning LaTeX. And like, hey, the author is me. So that doesn't really say, like use this, like make text here. What it's saying is just kind of providing LaTeX some meta information. And then when we use the make title command, we see that it actually creates the title. Cool. Another thing you'll notice is that make title is an instance of a command that just kind of has a name, but then no arguments, unlike the ones up here that had an argument. So that's an important note. Alrighty. So another thing, right, is one would expect that if we're typing a paper, I would insert a new line by hitting enter here, right? So if I want to say like this is the second line, and then say like this is the third line. However, you'll notice that even though these are on different lines in the source, in our actual document, they'll be on the same line. And that is because in LaTeX, one new line like doesn't actually indicate to LaTeX to create a new line. So the obvious next question is, okay, well then how do you create a new line? That's a pretty basic operation. And there are kind of two ways to do it. The first way to do it, and kind of the easiest solution to our problem, is that we can just kind of type / at the end of each line here. And that just inserts a new line. So if I recompile this, you'll know that these are on separate lines. But there's also another way, and that is by creating an entirely new paragraph. And how you do that is by hitting enter, not once, but twice. So then you'll get an empty line in between the previous one. And then we can say, like, this is the second paragraph. And then you can type all the stuff you want, including all of the stuff that is so eloquently in the README that I'm going to copy. Except it's going to put a bunch of new lines, but that's fine. We just kind of like, okay. But if you recompile this, you'll notice that we'll have, ooh, it's going to take a little bit. Okay, we'll have a new paragraph, right? So you see that that big chunk of text is on a new line. And then another thing that you might notice a little bit subtly is that it's indented. So paragraphs are indented automatically in LaTeX. And that's just kind of a stylistic choice. that it uses. And I kind of don't like it. I'm sure some people will argue with me. They'll say, no, this is like how paper should be formatted, and blah, 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 blah. But let's just work on the premise that like we don't want that. Well, you can remove it. But oh no, I don't know how. So this is where Google becomes really nice, right? So it's impossible to teach all of the what you can do in LaTeX. Like you'll almost never learn it all. It's just there's so much stuff. It's kind of like JavaScript in that way. But a lot of stuff is very Googleable. So if I want to say remove, oops, that is the Zoom chat. Remove indent from paragraph in LaTeX. And then I'm gonna use this one because this one says overleaf on it and I like that. It has, I'm gonna make sure my internet didn't bug out. Good. It has information on how to do this. So if we go to paragraph indentation, it says, oh, look, you can set the length of a paragraph indent. So let's do that, right? So we can just copy this. And then you see, oh, we put this above document, right? So let's put this above document and we'll set it to 0. All right, now we got rid of the paragraph indentation. And then another thing we can do is set the spacing. So if we go back, we'll notice that there's like a section of paragraph spacing and then you see it's called par skip. And we can also set this. So if I want my paragraphs to be spaced apart, but not necessarily indented, it's like pretty easy. You can just, Google is really nice. There's a lot of resources. Alrighty, with that aside out of the way, let's continue with sections. So you'll notice in a lot of academic papers and such, you'll have sections and it'll go like section 1, introduction or something. And LaTeX makes that really easy. So it's another command. So we start commands with a backslash, and it is very conveniently the section command. And it takes an argument that is the name of the section. So down here, I might be able to say like more silly me, LaTeX. And then maybe I make a section up here. I'm not supposed to be no, we're good. So we make a section under the title, we'll call it introduction. So that's really cool. Oh, you can also make subsections. So let's just see what these sections look like first. So you see over here, we have 2 sections. Great. Another thing you'll notice is that this kind of LaTeX here is formatted kind of weirdly, you know, and that is because it's this command. So backslash LaTeX will give you kind of this fun formatting of LaTeX. Alrighty, so in addition to sections, we can actually include subsections as well. So if I want to say under here backslash subsection, and then say Donald Knuth fun fact, and then maybe below here, I can make a subsection called how to make sections. And then we recompile it. we'll be able to see that we have these nice little subsections now. So that's pretty nice. So and then in our subsections, our subsection, there. We can like just kind of type anything we want, right? So we can say we can use the text backslash. So I'll show you what this command does, but you might be able to guess. Section and text backslash subsection command. Alrighty. So if we compile this, we get this nice little part of our paper that says how to make sections and subsections. And you saw me kind of use this weird text backslash command. That is because I can't just put a backslash in front of section, because I mean, if I did, like, then it just looks like a section command. So I actually can't just use the backslash like that. I have to use a special command to insert a backslash. If your eyes are very good, you will notice that while there's a space here, there actually isn't one in front of the backslash, the actual backslash. So that's just kind of a syntax thing. But if you do want a space, you can put curly braces afterward, and then you should get a backslash and then a space and then section. It's just for knowledge's sake. yeah, Windows path names are going to be kind of hard here. I'm sure there's probably a convenient solution to that actually, but I don't know it off the top of my head. Okay. So I think we talked about everything here. If you have questions, feel free to drop them in the chat. You see text backslash is another example of a command that takes no arguments. So it's just slash and then a command name. So similar to the LaTeX command. So backslash will put a backslash, but backslash LaTeX will put in this fancy LaTeX. Wow. Alrighty. So subsections and sections seem kind of lame, a little bit. You know, it's like, yeah, okay, you put a number 1 and then kind of in bold. I don't think it's actually bold, but in like big letters, you put introduction, like, wow. But there's actually great power in sections and subsections. And in part, we get a table of contents really, really easily. So if we want to just slap in a table of contents, actually don't know where the correct place to put it is, but this is a table of contents command. And we just kind of pop it in. And then we get, just for free, we just get a table of contents. And the page numbers will update. And as you add more sections, those will be updated. So that's really, really convenient. Alrighty. So that's really great that we kind of unlocked from we have LaTeX summon from the dark abyss, a table of contents for us. One thing that we kind of overlook here, it look really, really close. If you look at Donald Knuth fun fact, you will notice a horrible sin has been committed. Do you see it? We see a closing quote where an opening quote should go. Gasp. I know, the humanity. So let's atone for that horrible formatting sin. So you can explicitly specify that a quote is an opening quote by, instead of typing the quote character in your file here, you can type 2 backticks instead. So if we compile, we should see that this turns into an opening quote, and all is balanced, and the Fire Nation lost the war, or whatever. If you want a single quote, so let's say we want to put a single quote around Donald Knuth, you just use a single backtick. And if you don't know where the backtick is, it is usually right above the tab key. So now we have opening single quote and then a closing single quote. Awesome. All right, so let's go to my favorite section, which is math. Math is so nice in LaTeX. It's one of my favorite. It's one of my favorite kind of features that it offers. So let's jump into that. I'm gonna make a new subsection. It is gonna be called, this may surprise you, math. And then I'm gonna zoom out on this document a little bit so people can actually know what's going on. Alrighty, so now we have a math section here. All right, let's bring up some basic math. So one of the first ways of kind of inserting math into a document is by inlining it. So we can say this is the Pythagorean Theorem. I always misspell this word. I've been taking theoretical math classes for like a whole year now, and I still can't get it right. And how you specify that something is math is by inserting it in between two dollar signs. So then we can type the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. All right, so now let's compile this. So we can hit Command and then Enter, or Control and then Enter. And we get this really nice Pythagorean theorem. Wow. It's all like italics. We have the exponents, you see. So this is kind of one of our first math things is this caret will specify that something is in the exponent. Another thing that's kind of neat to notice is like the spacing really doesn't matter. LaTeX just kind of does it for you. So if I want to like wonkily space this, and then I recompile it, you'll notice that the equation still looks good. It looks the same. And this comes with that, LaTeX cares about the content, and it will do the formatting for you. So that's great. So now we have like the superscripts here, like the exponent. Another thing that we might want is a subscript. So we can say, for example, oops, a system is linear. Linear if, oh, it's a bag. And then if anyone kind of remembers this, a sub 1 times x sub 1, that's like a whole thing of like, so we're just gonna type her out. Oh, nope, these are 2's. Is equal to a sub 1 times f of x sub 1 plus a sub 2 times f of x sub 2. I think that's right. And then we recompile, we get this, which looks right. So you say, oh, a system is linear if f of that is equal to that. So you pull the signs out, you get the addition out. So that's great. So now we can say like a definition for a linear system. So that's kind of inlining math equations, we put them kind of alongside our text. Oh yeah, and one thing to notice too, sorry. Our subscripts, right? So I say A and then an underscore, which means I want the next thing to be subscripted. Nice thing is it subscripts just the next character, so it won't subscript this X here. And if you want to subscript more than one thing, there's a way to do that, and we will show you. But yeah, so this underscore means subscript the next character. Pretty cool. Okay. So we have a paragraph that I'm just going to copy from the README because I don't want to type it. You don't have to type it either, don't worry, because it's not relevant. If you're following along. All right, so we have Euler's formula. But let's say instead of inlining it, we want it to be kind of like, if you've seen like a math textbook and it's like, it has some wall of text and then kind of an equation kind of centered on the page on its own line. We kind of want that this time around. So you can do that pretty easily by typing a backslash and then a open bracket, followed by a backslash and then a closing bracket. And then in between those two things that we type, we can type equations as we always did. So let's type some stuff here. So we can say e to the, then it's like this big equation, I pi is equal to cosine of x plus sine of x. And I'm going to talk a little bit about, oops, sorry, maybe there's an I here as well. Silly Tim. So I talk about a few things. So we're going to compile this. And then we have some unforgivable formatting sins. Oh no. All right, so first things first, the most glaring issue. Our pi is not in the exponent. And that is for the reason I kind of told you guys before, is that this caret will only put the next character in the exponent as like a superscript. If I want a chunk of text to go in the exponent, you can put curly braces around it. And this means that I will raise, like I will put in the superscript, like in the exponent, anything in between these curly braces. So then if we recompile this, you'll notice that pi will be in the exponent. Awesome. Okay, but we're still not out of the water. So the next thing is that the cosine and sine are actually not formatted super well, because these are functions, right? But right now, they kind of look like it's the variable c, some variable o, and some variable s. So if we want it to be like, oh no, this is a cosine function from trigonometry, you can actually just put a backslash before cosine and sine. There are LaTeX commands for cosine and sine to format them correctly in math. So after that, you see that oh, silly. Yeah. I mean, I guess you could just write like e to the I pi is equal to, and then just put pi here, but that doesn't really mean much because it's just 1, I think. No, it's negative. It doesn't matter. It's x here. That was Galen's point. Oop. There we go. So now we have our cosine and sine commands. And then one final thing is generally in math, we have like the sentence, right? We have Euler's formula states that for any real number x, and then this whole chunk. But this formula is actually technically the end of a sentence. So a lot of times you'll actually see people put a period here. It's like a little formatting nuance that particular people may desire in like a formal piece of writing. Alrighty, so we superscripted more than one symbol, right? Great. That's a good point. Okay, we have the sine and cosine commands, which we explained. One thing that we kind of lost by not having pi here was the Greek letter, but a student in chat eloquently put that we should use theta here because it's an angle, right? So we can actually still show how you type Greek letters in LaTeX. So now we have a theta here. Very nice. So you see that just backslash theta if you want theta. That applies for like pi, omega, whatever. A neat little trick is if you want a capital theta, you can just capitalize the T usually, I think. Yep. Yeah. So that applies for most of the Greek letters, I believe. But we're going to use a lowercase theta. So, yeah. Alrighty. Do you know what math has? Oh, a wonderful thing called fractions and summations, and this thing called a Taylor series. Oh my gosh, I'm so happy I don't have to do these right now. I used to, but now I don't. So while you guys are coping with the existential dread that has been just dredged up from the bowels of your soul at the sight of the forbidden math thing, let's talk about a few things that we can do when formatting and typesetting Taylor series. Alrighty, so what we want is the Taylor series for each of the x at a equals 0. Okay, so like before, we're gonna put this in like its own line. So that's we get our backslash and then bracket. Alrighty, let me show you what we're trying to do because it's not going to make too much sense. So get ready, guys. A trigger warning, math. Here's a Taylor series. So you see we have a sum. We have n equals 0 below it and infinity on top. And then we just have a bunch of fractions added together. And then at the end, this little ... Alrighty, so let's try to do that. Ooh, oops, wrong tab. Here we go. Okay, so the first thing we want is the sigma. So LaTeX actually has a very nice way of doing this. You can literally just type sum. The sum command will put a sigma for you. Beautiful. So now we want n equals 0 below the sigma and infinity on top of the sigma. And that's actually, like, I've always found this pretty intuitive of like how you put it stuff below and on top of the sum is you're just like, it's just like you are subscripting it, right? So you can kind of subscript n equals 0 on the bottom, and then immediately afterwards, you superscript a infinity symbol. So usually when something's a symbol, there's a command for it. In this case, it is inft. So we see that here. And then we should get the sum with n equals 0 on the bottom and infinity on the top. All right, now we have to write a fraction. I don't like fractions. That's my personal opinion. They always give me trouble, make my math harder to do, but we have to do it for the sake of, I'm typing in the Zoom chat, curses. Fractions actually, LaTeX makes them a lot nicer to format at least. Is that there's a command, right? It's a frac command. So this is the first command that we're going to do that takes more than one argument. So frac takes two commands, one for the numerator, which is the first argument, and the second one is for the denominator. So we saw before that there's x to the nth power on the numerator. So that's pretty easy. We just do x to the n. And then below it, we'll see n factorial. So n and then yeah, exclamation point here. So if we do that, we get this nicely formatted Taylor series. And then we can type the rest, right? And that's pretty repetitive. So we have frac x to the 0 over 0 factorial plus frac x to the 1 is 1 factorial. And then I'm not going to type the other ones, but we have this kind of dot, 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 which we can also do like so. We say c dots, I believe is the command. And then we get this. So you see we have our kind of, it's expanded out here without the sigma, and we have our little 3 dots. So that's pretty cool. Alrighty. Yeah, so one of the big things to note here is like with the fraction, we have 2 arguments, which is pretty cool. Yes. Okay, so LaTeX actually has a lot of kind of features, especially over tech. However, there are some things that it doesn't support kind of inherently. However, people have kind of solved this problem by creating packages that you can include in your document that provide extra features. So, for example, one thing we might want to do is create a matrix, right? So now we're shifting from, I don't know, calculus or wherever you see Taylor series, and we're going to linear algebra land, or yeah, quantum computing even. And we want to type a matrix. And matrices are very complicated for like formatting. It's just big fat thing. It takes up way more than one line. You have like numbers below other numbers. So there's actually a package to help us with this. So if you want to include a new package, so this is where we are right now. Matrix goes here. You can scroll up to all the way pretty much above everything except document class. So under here. And you can use the use package command. So we type use package and then the name of the package. So the one we want to use is called AMS math. And you can see it's actually very common because it is the third thing that is suggested. So AMS means, it stands for the, I think it's the American Mathematical Society. So we have a package from like for pretty much math stuff. And that's really nice. It's a very common include. So I would say this is probably one of the essential packages you'll be using, especially if you are typesetting math. All right, so we included that. So now we can use it. So let's define a matrix. What matrix are we going to do? We're going to do a rotation matrix. So I'm going to type out the set of all 2 by 2 rotation matrices is, ooh, spelling, never been good at it. Defined as such. And then we want to put a matrix here. So similarly to before, we are going to have this go on its own line and be centered. So we'll use our backslash brackets. All right, let me show you what we want to make. Hold on, let's find it. This is what we want. Alrighty, so we got these big curly braces, and then we have a matrix here, and then it's like for theta between 0 and 2 pi. So I think the first thing I want to do is kind of the most complicated part, which is the matrix. So let's create that. So we talked about environments before. For the document environment, AMS Math actually defines an additional environment that we can use called P matrix. And then we end it there. Alrighty, so let's just try typing something in this environment and see what happens. So let's just do the first thing in a matrix, which was cosine of theta. And let's compile it and see what happens. Alrighty, so we have the set of all 2 by 2 rotation matrices is defined as such. And then we have kind of a matrix with 1 element in it. Very, very refined. So we can add an additional element like this. So let's add the one to the right of it. So we can put an ampersand here and then say minus sine theta. All right, and then let's save it and see what happens. So now we have a 1 by 2 matrix. Yeah. So that's pretty cool. I made a small formatting issue, but I'll fix it after we do the matrix so I can explain it. All right. So how we get the 2 terms below it is we can define a new kind of row, kind of like the new line from before. So we use 2 backslashes to indicate that the next stuff that we're going to type is on the next row. And then we pretty much just do the same thing. So here we have sine theta, and then cosine theta. Alrighty. And then if we compile this, we should get this matrix. All right, so that looks pretty good. So this is pretty nice. It's kind of just a handy way of defining a matrix. So the formatting error I was talking about was this new line we actually kind of don't want here. If you look at our document, like this is kind of a lot of space to have between like our matrix and the previous line. And that's because I have an extra new line here, which we don't want. So it's kind of in its own paragraph. So you'll notice that once I delete it, this kind of nudges a little bit closer and looks a little bit more uniform with the rest of what we typed. All righty. So now let's add, so we'll add this part, the 0 is less than or equal to theta is less than 2 pi. And that's actually pretty straightforward. So we can do, the colon, and then 0 is, oh boy, less than or equal to, I guess. Come back to that. Theta is less than 2 pi. And if we recompile this, we should get this almost niceness. So obviously there's no less than or equal to key on your keyboard. So like most things, if it is a symbol that you might struggle to type because it's not on your keyboard, there's a command for it. And this one is LEQ, so less than or equal to. So then if we recompile it like this, we will get a nice less than or equal to sign right here. Pretty cool. All right, the last touch is the curly braces, right? So we have the curly braces on the edge. How do you do those? Well, the one thing we talked about before was that curly braces are special, right? So we have to put a backslash before them to say, hey, I want this to be an actual curly brace instead of one that's relevant to command. So we say backslash curly brace at the front, backslash curly brace at the end. And then we try, we're like so excited. Oh my gosh, we put our curly braces in, we're almost done. And then you see this cute little curly brace that's way too small. Yeah, so obviously our matrix is making our curly brace look a little small. So how you can fix that is by putting before the curly brace, before the, here both the backslash and the curly brace, you can put the left command, and then after, before the last backslash curly brace, you say right. And what this will do will automatically kind of resize your curly braces so they can properly enclose the equation in the middle. So now we get some big curly braces, and that's great. And then we finished, right? We have our matrix, so that's really nice. And I'm just like, it would be a lot harder to type something like this in Microsoft Word or, oh God, heaven forbid, Google Docs. Oh, no. So a few things I want to talk about really quickly. You might be wondering, like, what is this ampersand for? Generally, you'll put these in between, like if you have like a grid of stuff, usually put ampersands in between like elements in like one row of that grid to say, this is so LaTeX will know how to align the like elements in your matrix. So it's like, if you think of like the ampersand as like an invisible like wall between cosine theta and minus sine theta, LaTeX will try to align like the first like of each little wall in each row. So that's how it kind of makes it look so nice. Okay. So I'm gonna hop back to the slides, which is this way. Huzzah! Alrighty. So a quick additional note on packages. There's a ton of packages, and one of the coolest things about LaTeX is that for most of the stuff that you might want to do, there's a package for it. So we have auto syntax highlighting of code. We have drawing chemical molecules, or even just drawing generic stuff like diagrams. I added a little bit about what we might consider some essential packages. We saw for formatting equations, we had AMS math, but we also have microtype, which I'm not quite as familiar with. However, it does a lot of tiny little formatting changes to kind of compact your paper. A lot of people say it looks better, but that's quite subjective. But this is a very common one, and it's pretty cool. And then we also have hyperref, which is for adding hyperlinks to your document. So this is pretty useful for references, but also if you like have equations that you refer to in your paper, this is really nice. If you ever read a math textbook and then you have like exercise 11.2, like apply the new thing you learned to all of the exercises from 2.5, and then you just kind of groan because you have to click back to chapter 2. This helps with that. Hold on. Okay. When in doubt, just Google it. It's kind of seems like bad advice, but I really mean it from the bottom of my heart. You'll never, like, even if like you're good with LaTeX, you're just gonna be Googling constantly. A friend of mine, he told me, he's like, yeah, I can't use LaTeX without an internet browser. So it's very important to know that like you probably won't know everything, and that's fine, because the mastery of LaTeX comes with the mastery of being able to figure it out. Another additional note, places that support LaTeX. So Facebook Messenger, believe it or not, technically supports LaTeX to some extent. It's a desktop version, but if you type, I think it's between two, I think it's the same as inlining. So if your entire message is between two money signs, you can write like equations like this. So you see my bud Kevin eloquently dissing Connie. We also have Piazza. So a lot of classes at UCLA, especially STEM-focused ones, use Piazza. That actually supports LaTeX for equation editing, which is really nice. So that's why if you ever wonder, like, how do people make their equations look so good? It's probably because they've embedded LaTeX. So yeah. Okay, so I think one of the best ways of learning LaTeX is by doing it yourself. So we put up some kind of exercises to test your skills. So we have the Maxwell's equations, I think, and then here we have a proof of the derivative of cosine. So yeah, that's like the kind of the final thing. So we'll be around, and feel free to like ask questions about anything really. So yeah, because the last slide I think is the feedback form. So if someone wants to throw the feedback form into the chat, feel free, as in like a hack person. Yeah, but otherwise, work on this and see if you can do it. If you have time to stay with us, you can ask questions and I'll do my best to answer them. But yeah, that's all the content I've prepared. So yes, end of file, I guess. I'm gonna stop the recording. So feel free to, I don't think I have chat.